Hi, today we'll be going over section 3.5, a review of factoring. In this video, we'll talk about factoring perfect square trinomials and factoring the difference of squares. First, perfect square trinomials. A perfect square trinomial is a trinomial that can be written as the square of a binomial, a perfect square. Like 2 squared is 4 or 3 squared is 9, a perfect square trinomial has a special pattern. A plus b quantity squared will always be a squared plus 2ab plus b squared. There's 2 of that middle term. And a minus b squared will be a squared minus 2ab plus b squared. There's 2 of that middle term. Okay, how can I factor a perfect square trinomial? How do I know it's a perfect square trinomial? Well, once again, we think about undoing. If I have a squared and b squared, how do you undo that to find a and b? You take the square root. So I look at my first term and my third term. What is the square root? A and B. I see if they're both squared terms and if I can take a square root easily. And then I see if the middle term is twice A times B. Let's try it in problem 17. I see a trinomial 49z squared minus 14z plus 1. How do I know if it's a perfect square trinomial? I take the square root of the first term and the third term. This would be 7z, this would be 1. Then I ask myself, is 2 times 7z times 1 equal to negative 14z? 2 times 7z times 1. Yes, but where's the negative? That comes in the template. Is it a plus b or a minus b? Now I know that a is 7z and b is 1, and if this is a quantity squared, this denotes that it's negative. 7z minus 1 quantity squared is 49z squared minus 14z plus 1. Awesome. Let's try it again. How do I know if this is a perfect square trinomial? I look at the first term and the third term. The first term, the square root, would give me 3a. The third term square rooted would give me 8. Is the middle term 2 times 3a times 8? 8 times 3 is 24. 24 times 2 is 48. And there's the a. Yes, that means this is a perfect square trinomial where the a and b term are 3a and 8. But what's the sign in the middle? I look right here, plus. Perfect square trinomials. If you don't notice that pattern, you can always factor these using the X method, rewrite, or the circle it up method, or the box method. But if you see the pattern, it's that much faster to factor a perfect square trinomial. Now let's talk about the difference of squares. The difference of squares factors to conjugate pairs. So a plus b, a minus b. Notice that each term is a difference of squares. Make sure anytime you factor out the greatest common factor. Then count how many terms. If you have 2 terms, then it's a special pattern, either the difference of squares or the difference or sum of cubes, which you'll learn about in a minute. All right, x squared minus 4. How do I find a and b? What we just talked about. Take the square root. So a will be x and b will be 2. Then plug it in to your pattern, x plus 2, x minus 2. Let's try this one. Is there a GCF? No. So take the square root. Notice the sign in the middle is subtracting the difference of squares. The square root of the first term is 4x. The second term is 3. Then plug it to your pattern. 4x plus 3, 4x minus 3. That's how you solve using the difference of squares. Let's try a couple more. Is there a GCF I can factor out? Nope. So I just go for the square root of each piece. The square root of 144y squared would be 12y. The square root of x squared is x. Then you plug it into your pattern. A plus b, a minus b. That's it. Look at problem 22. Take the square root of both sides since we figured there's no GCF to take out. And this would be 3x, and this one would be 5. Then plug it in. 3x plus 5, 3x minus 5. You're all set. Just remember, you cannot factor the sum of squares. Notice with the difference of squares, when you go back through and distribute, the middle two terms add to 0. But here, there's no way to factor this and break it down into a binomial. If I thought it should be x plus 2, x minus 2, the middle term would add to 0, but the last term would be negative 4, not positive 4, so that won't work. Anytime you see x squared plus 4, know that this is called prime. Thanks so much. See you next time.